This question is a quadratics question, and we're going to be modeling with that quadratic. In this one, we're having to find the equation. We're not actually given it, so we have to use a little bit of algebra to be able to do that. So it's a very typical question, and we're told that this ball is thrown and it makes this kind of arch shape. And we actually have 3 coordinates that we're told that the ball passes through. So it says using the first one of those, I need to write an equation in terms of A, B, and C. Now this is the equation that I know the whole equation has, and I know that when x is 3, y is 2.36. So I'm going to use that to write an equation. So in terms of my y value, I'm going to call it y rather than f. I have a times x squared, which is 3 squared. So that's my x value, which is the x part of my coordinate, plus b times x plus c. And I know that the y value is equal to 2.36. So now I have an equation written in terms of a, b, and c. You would actually get the mark for leaving it like that, or you can tidy it up and make it a little bit nicer, in which case you would then write that as 2.36 is equal to 9a plus 3b plus c. So it's just tidying it up a little bit. And then part B says use your answer to part A and 2 similar equations. Because it says this, you do have to use 2 similar equations in order to get the full 3 marks. Now we have 2 more coordinates given to us, so in exactly the same way, we're going to write some more equations. So for the second one, the y coordinate is 5 and the x coordinate is 10. So it is equal to a times 10 squared plus b times 10 plus c. And again, if I tidy that up, that's 5 equals 100a plus 10b plus c. And then the third equation is 7.16 is equal to a times 17 squared, 17 squared, plus b times 17. And then at the end there, I still have my plus c. Now again, if I wanted to tidy that up, it would just be 7.16 equals 289a, and you can use your calculator there as well, plus 17b plus c. So I now have 3 different equations, this one here, and this one here. Using those, I can then find the equation of the overall function. So I'm going to use the apps and polysimult 2, and I'm going to do simultaneous equation solver. So I have 3 equations with 3 unknowns, and I'm going to go to next, and I'm going to type in those 3 different equations. Now, if you prefer, if we go through that again, yeah, that's fine. So we're going to type in the first one. You can see here we have 9a, 3b, and 1c. So we're going to do 9a, 3b, and 1c, and that is all equal to 2.36. And then the second equation, we have 100a, 10b, and 1c. So 100a, 10b, and 1c, and that is equal to 5. And then the last one, I have 289a, 17b, and 1c. Now we can see there I've made a typo. There we go. And that is equal to 7.16. Once you have everything typed in, then you are going to solve, and you can see you get the answers here for what your values would be. You can leave them as a fraction, or you can press this button here fraction to decimal conversion, and you can see you get the decimals as well. It doesn't matter which you want to leave your answer as. I'm going to leave mine as a decimal, but it really doesn't matter. So y is equal to negative 0.00490 to 3 significant figures. I need the O there, plus 0.441x plus 1.08. Okay, so that's my, let me move that across a little bit. So that's my equation, 1.08. That's my equation to the function. So now that I have that, I can use that in part C and part D. If you weren't sure how to do that, then you could also go to, if we come out of this, if you go to statistics and edit, delete any data that you already have in there. And you could actually type in the 3 coordinates that we had. So 3, 2.36, and then 10, 5, and the last one was 17 and 7.16. And then if we go to statistics, calculations, we know that it's a quadratic, so we can actually find the quadratic regression. And we calculate, and that gives us exactly the same answer. The fact that r squared is equal to 1, that confirms for us that it's exactly correct. So if you're not sure how to do that, you could still get the method or the answer mark for the final answer, and that would allow you to then get methods in part C and part D. So that's a good way to use it as well. So we now need to show that the model predicts that this ball is going to go over the fence. So the fence is at 80 meters away and it's 4 meters high. So we're going to go to the y equals, and again, if you've got anything in there, let's just delete it. And we're going to type in the equation we've got, or that we just found. So it's negative, make sure you use the correct negative key, 0.00490 x squared plus 0.441 x plus 1.08. And if we graph this, now obviously our graph isn't looking at the right place. So we can see that ours goes from 0 to, well, it must be more than 80. So let's maybe set it to 100 for now. So on the x-axis, we need to go up to 100. Whoops, a bit too high. And let's try again. Perfect. Now we can see what's happening a little bit clearer. We want to know what value is the graph at 80. So to do that, we can do second function trace value, and we just say what happens at 80. And we can see there that the y value is 5. Okay, so you can either use your calculator like that to show that it goes through 85, in which case you can then say that since the fence is only 4 meters, it does go over it because it actually goes 1 meter above the fence. Or you can take the equation that we had and you can substitute in x is equal to 80, which is the distance away of the fence, and then you can calculate what that gives you, and it will also be 5, and that would also be fine too. Okay, I would say using the calculator is probably the easier option. And then part 8D is to find the horizontal distance that the ball will travel when it hits the ground. So it's basically asking for this coordinate here where it hits the ground. So we know on the calculator that's second function trace and 0. So make sure you go to the left of the 0 coordinate and then to the y, to the right, and then if you press enter, it finds the intersection in the middle with the x-axis, and that's at 92.4 to 3 significant figures. So it crosses here at 92.4, 0, and that's that coordinate. So the place that it hits the ground is 92 meters and 40 centimeters. So in terms of the marks for this question, there is one for either of the forms for the first equation. There is one each for the two equations that you found, and then one for the final answer of the equation. And then at the end here, you needed to show that it goes over the fence. So you can either substitute the value in, or showing this coordinate here actually gets you 2 marks, one for the X and one for the Y. And then there is also a reasoning mark for explaining that you know it still goes over the fence and why. And then the last one is that the ball hit at 92.4. One is for the answer and one is for any sort of method. And you can show that you know that it's the coordinate point here that you're trying to find. You could also show that it's when y equals 0. Okay, and that would also be enough for that final method mark.